Way out there, in the icy darkness beyond Neptune, something weird is happening. It's like an invisible giant, maybe 5 to 10 times bigger than Earth, is secretly pulling the strings of distant, frozen worlds. Now, this isn't some sci-fi story, it's a real head-scratcher that has astronomers all over the world buzzing. What if our solar system has been hiding a secret all this time? For ages, we thought we had a pretty good handle on our planetary family. We learned their names, their order, and what they were like. But the universe, as it loves to do, dropped hints that there was more to the story. Strange, unexplained gravitational tugs and odd patterns in the orbits of the most far-flung objects in our solar system started painting a really interesting picture. The chance that a massive, hidden world is out there. For now, they're calling it Planet X, or sometimes Planet 9. This isn't the first time we've gone looking for a Planet X. The name itself has a bit of a history. It was once used for a hypothetical planet beyond Neptune that astronomers thought was messing with Uranus's orbit. That particular hunt actually led to discovering Pluto back in 1930. But Pluto, which got reclassified as a dwarf planet in 2006, turned out to be way too small to cause the disturbances that started those old Planet X theories. Today's Planet X is a whole different kettle of fish, a much bigger deal, proposed to explain a fresh set of even more puzzling behaviors way out in the Kuiper Belt. This modern search is fueled by some pretty convincing, though still indirect clues, and it's kicked off one of the biggest astronomical detective stories of our time. So why is this phantom planet such a massive enigma, capturing scientists' imaginations and ours? Let's explore the shadowy edges of the outer solar system. The modern story of Planet X doesn't start with someone actually seeing it. Instead, it began with faint whispers from the cosmic darkness. Back in the early 2000s, especially around 2014 and 2016, astronomers like Scott Shepard, Chadwick Trujillo, Konstantin Batygin, and Mike Brown started noticing something odd. They were studying a bunch of small, icy bodies beyond Neptune, known as trans-Neptunian objects, or TNOs. Specifically, they were looking at a group called extreme trans-Neptunian objects, ETNOs, which have these incredibly long orbits, taking them hundreds of times farther from the Sun than Earth is. And what they found was pretty strange. Several of these ETNOs had orbits that were all bunched together in a really unusual way. Picture a bunch of race cars, and for no clear reason they all decide to stick to the same side of a giant racetrack, their paths all tilted at similar angles compared to the main track where the other planets go. This kind of alignment was a surprise. If these objects were just doing their own thing, their orbital features, like how close they get to the Sun or the tilt of their orbits, should have been all over the place. When they ran the numbers on these clustered orbits, the chances of it happening by sheer coincidence were tiny, maybe as low as 1 in 1,000. This was the first big hint that some unseen gravitational force was bossing these distant objects around, nudging them into these peculiar paths. It wasn't just one or two stragglers, it was a pattern, a subtle sign that the outer solar system might be keeping a pretty big secret. These early observations really laid the foundation for the Planet X idea, turning it from an old story into a serious scientific puzzle. These oddities suggested our map of the solar system was missing a pretty important piece. The main clues for Planet X, the kind that really get astronomers' attention, are hidden in the weird dance moves of these distant Kuiper Belt objects. The Kuiper Belt is this huge, donut-shaped zone of icy bodies, leftovers from when the solar system was forming, stretching way out past Neptune. It's home to dwarf planets, comets, and tons of smaller stuff. And in this faraway crowd, a specific group of ETNOs has orbits that aren't just clustered, but their long, stretched-out paths also point in roughly the same direction in space. Think of it like this: if you tossed a handful of sticks in the air, you'd expect them to land pointing every which way, right? But what if a whole bunch of them landed pointing, say, mostly east? You'd start to suspect something was influencing them, like a steady wind. For these ETNOs, the wind is thought to be the gravity of a huge, unseen planet. Computer models run by astronomers Konstantin Batygin and Mike Brown in 2016 showed that a planet, about 5 to 10 times Earth's mass, in a faraway stretched-out orbit, could naturally explain why these orbits line up. This theoretical Planet 9, as they called it, would act like a gravitational shepherd, slowly shaping the orbits of these smaller ETNOs over billions of years. More evidence backing this up includes objects with really tilted orbits, leaning dramatically compared to the flat plane where the known planets orbit. Some ETNOs even have orbits that are almost perpendicular to that plane. Planet 9's gravity could explain how these objects got yanked out of the solar system's main plane and why they stay on such wacky paths. Also, some Kuiper Belt objects have orbits that cross Neptune's path, but somehow stay stable over eons. Planet X could be the reason Neptune's gravity doesn't just kick them out. Fresh analyses in 2024 by Batygin and Brown, looking at TNOs with low tilts that cross Neptune's orbit, added more weight to the idea, suggesting these objects could only get slingshotted into the inner solar system if another planet was out there doing the slinging. Simulations show that if Planet 9 exists, it would, over time, nudge a good number of objects into orbits that intersect Neptune's. Now, while the evidence is pretty strong and comes from different angles, it's still all indirect. Nobody's actually spotted Planet X yet. So, if the clues point to a hidden giant, how are scientists actually trying to find it? Well, looking for Planet X is a massive undertaking, really pushing the limits of our telescopes and search methods. It's like trying to find a very dark needle in an absolutely enormous cosmic haystack. The main strategy is direct imaging using incredibly powerful sky surveys. Astronomers use some of the world's biggest telescopes, like the Keck and Subaru telescopes in Hawaii, to scan huge areas of the sky. They're looking for faint specks of light that move super slowly against the background of faraway stars. Because Planet X would be so far from the sun, it would reflect very little sunlight, making it incredibly dim. Scientists guess it could be orbiting anywhere from 200 to 800 times the Earth-Sun distance. An orbit that big could take between 10,000 and 20,000 Earth years to complete. Infrared sky surveys are also a big help. A planet this size, even if it's cold, might give off a faint infrared glow from its own internal heat, or it might reflect the faint sunlight in infrared wavelengths. Missions like NASA's Wide Field Infrared Survey Explorer, WISE, have scanned the whole sky, and scientists, including citizen scientists in projects like Backyard World's Planet 9, carefully sift through all that old data looking for the telltale signature of a slow-moving distant object. In fact, some recent studies have flagged potential candidates from this old infrared data, though these need a lot more observation to confirm. Smart motion detection software is also key. Computers look through sequences of images taken days, weeks, or even years apart, trying to spot any object showing that slow, steady movement you'd expect from a distant solar system body. But because the signal could be so faint, humans often still need to double-check these potential finds. Besides trying to see the planet directly, scientists also look for its tiny gravitational effects on things we already know about. By tracking the orbits of our existing planets with super high precision and even the paths of spacecraft like Juno and Cassini, they can look for tiny wiggles that might give away the presence of an unseen mass. They use advanced statistics and complex simulations to try and narrow down Planet X's possible mass, orbit, and current location based on any gravitational footprint it might be leaving on the outer solar system. The sheer amount of data and the computing power needed for these simulations are just mind-boggling. Even with all these clues and fancy search methods, finding Planet X is a huge challenge, and not everyone in the science world is convinced it's out there. The biggest problem is just how incredibly far away and faint it would be. If Planet 9 exists, it's so distant from the sun that it reflects hardly any light, making it an extremely dim target. As Dr. Bloomer from the Daily Galaxy pointed out, Planet 9 would mostly be reflecting sunlight, not making its own light like a star. The search area is also just gigantic. Even with predictions about where it might be, the sky is vast, and Planet X could be anywhere along its predicted path, a tiny, slow-moving speck in a sea of stars. Spotting such a faint object against all the background noise of the cosmos is a major technical headache. Even if a computer flags a pixel that's a bit brighter than it was a few days ago, it takes careful follow-up to make sure it's not just a glitch or some known fainter object. Some astronomers think the way those ETNO orbits are clustered might not be because of a giant planet at all. Instead, it could just be that we're biased in how we're looking. Because these distant objects are so faint and hard to find, maybe we're only spotting the ones that happen to be in certain parts of the sky or in orbits that make them a tiny bit easier to see with our current equipment. The Outer Solar System Survey, OSSOS, for example, suggested that the clustering might be due to these kinds of biases, plus the fact that we haven't found that many of these objects yet. If we've only seen a small, skewed sample, the apparent clustering might just vanish as we discover more. People have also come up with other ideas to explain what's going on. Some theories suggest the gravitational pull might be coming from a scattered disk of smaller icy bodies, like a second more spread-out Kuiper Belt instead of one big planet. Others have even wondered if our understanding of gravity itself needs a tweak, maybe with something like modified Newtonian dynamics, MOND. MOND suggests gravity might act differently at really low accelerations, like those in the outskirts of galaxies or maybe even the far reaches of our solar system. These alternative ideas show just how complicated the problem is and why we need more data. The debate is definitely still raging, with new data and better statistical tools constantly shaping the arguments for and against Planet X. The hunt for Planet X isn't just some cosmic treasure hunt. Finding it, or proving it's not there, would completely change how we see our solar system and how planets form in general. If confirmed, Planet X would mean rewriting the textbooks. It would mean our solar system has a type of planet, a super-Earth or mini Neptune, much bigger than Earth, that we see all the time around other stars but seems to be missing from our own planetary lineup. Finding one right here in our backyard would give us a crucial local example to study. Its existence would help solve many of the lingering mysteries of the outer solar system, like those weird etno-orbits, the super-tilted paths of some distant bodies, and why certain Neptune-crossing objects are so stable. It might even help explain the slight tilt of the sun's spin axis compared to the orbital plane of the planets. Planet 9's distant tilted orbit could be slowly pulling on the whole solar system, and the story of how Planet X got there would tell us so much about the wild early days of our solar system. Was it formed way out in its current distant orbit? Was it originally a giant planet core that got booted outwards by Jupiter or Saturn when the solar system was young? Or could it even be a captured rogue planet, a wanderer from interstellar space that got snagged by our sun's gravity? Each of these possibilities opens up amazing new ways to understand how planets move and how planetary systems across the galaxy get put together. Finding it would also redraw the very edges of our solar system and make us rethink how planetary systems are born and grow. It would really drive home the idea that even our own cosmic neighborhood still holds major surprises. This is exactly why the possibility of Planet X is one of astronomy's biggest puzzles right now. It pokes holes in our current theories, promises a deeper understanding of our place in the universe, and represents a real, discoverable piece of a giant cosmic jigsaw. The search for Planet X is gearing up for an exciting new chapter, mostly thanks to new telescopes coming online. The one everyone's watching is the Vera C. Rubin Observatory, being built in Chile, which is expected to start its legacy survey of space and time in 2025. This amazing observatory, with the biggest digital camera ever made, will scan the entire southern hemisphere sky over and over for a decade, cataloging billions of objects with more detail and precision than ever before. Astronomers think that if Planet X exists, and is as bright and as close as predicted, the Rubin Observatory has a really good shot at finding it. Mike Brown, one of the scientists who proposed Planet 9, has said the Vera Rubin Observatory is absolutely perfect for this job, and could potentially find the planet within its first few years of operation. The LSST won't just look for Planet X directly, it will also discover tons of new KBOs and ETNOs. This bigger sample size will be vital for figuring out if that orbital clustering is real, or just a statistical hiccup, because we haven't found enough objects yet. If the clustering holds up with more data, it'll make the case for Planet 9 even stronger. If it disappears, well, that could weaken the idea or suggest that observational biases were the real culprit. Even if the Rubin Observatory doesn't spot Planet X right away, the data it gathers will be super useful for narrowing down the search area. Some astronomers suggest that if Rubin doesn't find it within a few years, they might try using radio telescopes. Other ongoing surveys with telescopes like Japan's Subaru telescope are also chipping in. Recent studies are constantly fine-tuning what Planet X might be like and where it might be. For example, simulations in 2025 by Amir Siraj and his team, using a larger sample of TNOs, suggested a Planet X that might be about 4.4 times Earth's mass, orbiting closer and on a more stretched-out path than some earlier guesses, which could make it easier for the Rubin Observatory to find. But things are always changing. In May 2025, the discovery of a new dwarf planet candidate, 2017 of 201, was announced. It has an extremely wide and eccentric orbit that doesn't fit in with the clustered ETNOs. This finding could be a problem for some specific Planet X models, reminding us that the picture is still fuzzy and always evolving. The next few years are shaping up to be pretty decisive. The hunt for Planet X really shows off our human curiosity and our unstoppable urge to figure out the universe. It's a story of careful observation, brilliant ideas, and the thrilling edge of scientific discovery. Those strange goings-on in the far reaches of our solar system have given us some pretty strong clues, hinting at a massive hidden world that could completely change our understanding of our planetary home. While solid proof is still out of reach, the search is more active and looks more promising than ever. Whether Planet X is eventually found or its absence makes us look for other explanations for what we're seeing, the journey itself is pushing what we know to its limits. This ongoing puzzle reminds us that even in our own solar system, huge mysteries are still out there, hidden in the dark. So what do you think? Is Planet X out there just waiting to be found? Or do these weird orbital patterns point to something even stranger? Let us know your theories in the comments below. And if you want to keep up with this cosmic detective story and explore more mysteries of the universe, don't forget to like this video and subscribe to our channel.